Hi, I'm Paul. We're doing Leetcode must-know interview questions. Today's challenge is find median from data stream. All right, so this is listed as a heap question. What do they have here for topics? Heap, okay. 2 pointers. Oh no. Yeah, I don't know if we're gonna do 2 pointers. Let me think. Well, we'll see. Sorting. The heap. The priority queue would take care of all the sorting that we need. What else? Anyway, I'm sure there's more than one way to do this, but here's the challenge. The median is the middle value in an ordered integer list. If the size of the list is even and there is no middle value and the median is the mean of the two middle values. For example, array 2, 3, 4, median is 3 because the middle element for an array of just 2 and 3, the median is 2 plus 3 divided by 2 because 2 and 3 are the middle elements, the two middle elements. All right, implement the median finder class. There's a constructor. There is an add num, takes a integer num from the data stream, adds it to the data structure, and a find median method that returns a double and returns the median of all elements so far. If you're within 10 to the negative fifth of the actual answer, that will be acceptable. All right, how big are these numbers going to be? Let's see. Oh, okay. Well, 10 to the fifth. Between negative 10 to the fifth, between negative 100,000 and 100,000. Okay. Let's see. Can I squeeze this over a little bit? I want to do an example, but I want to have enough room. There's probably enough room there. Okay. Okay, so I think our life is going to be a lot easier here. You know, we did a problem like this, a challenge like this before. It was finding the median of two sorted arrays. Okay, so that was a binary search problem. But the idea was we could use a binary search to separate the numbers into two groups, where all the smaller numbers were in one group and all the larger numbers were in the other group. And based on that, we can figure out the median. And yeah, I think we can do the same thing here. I mean, this is rated hard. It's just hard. I think the implementation is not hard, but it's figuring out an algorithm to implement is hard. So our life is going to be a lot easier if we have two heaps. And we put the smaller numbers in one heap and we put the bigger numbers in the other heap. And by doing that, we can find a median. So let me get a pen here. We're going to have two heaps. We're going to have a min heap. Okay, and we're going to have a max heap. Now, when I say min and max, what I mean is that if we take something out, we're using priority queues. So in the min queue, if we take something off the front of the queue, it's going to be the smallest number in the queue. if we take something off the max heap, it's going to be the largest number in the queue. What it doesn't mean is that the smaller numbers are going to be in min and the larger numbers are going to be in max. That's actually reversed. Actually, the smaller numbers will be in max and the larger numbers will be in min. So that, let's see, is that right? Min, max, yeah, so they'll meet in the middle. I mean, if we take the numbers off of min and max, then they'll be those numbers will be adjacent to each other. So let's try an example here where we have median finder. We create a new median finder and then we add the number 1. Okay, so let's do this. Let's add 1 to the min heap. All right, and then let's take it off the min heap and put it on the max heap. Now, this doesn't make a lot of sense yet, but it probably will, as we get more numbers. All right, now we want to keep the sizes equal. So we want to keep the max heap size no more than 1 greater than the min heap size. Is that the case here? Yes. All right. So we can go to the next number. The next number is 2. All right. So we are going to put 2 into min heap. We're going to take it off of min heap and offer it to max heap. So max heap will go over here and it comes off of min heap. Okay. Now, max heap is too big. So we have to take an integer out of max heap and put it into min heap. Because it's a max heap, the number that's going to come off is 2. So 2 will come off of max heap and 2 will go into min heap. All right. Then there's a call to find median. Okay, find median. Okay, if the max heap size is greater than the min heap size, it's only going to be greater by 1. And whatever is on top of the max heap is going to be the median. However, if they're the same size, then we can just do a peek on both heaps, 1 and 2, add them together, divide by 2, and get 1.5, which is over here somewhere. 1.5. Okay, that is the correct answer. Now we're going to add 3. Okay, so what do we do? Min heap, offer 3. Okay, and now we take the first item in the min heap queue and offer it to max heap. Okay, now it's starting to make sense a little bit because the number that comes off of min heap is not the 3. It's the min. It's the 2. Okay, and now we call median. Find median again. All right. Well, if max heap size is bigger, then we just peak at the max heap, and that's the median. All right, peaking at the max heap is going to give us the maximum number in there, which is 2, and that is, in fact, the median. So let's go ahead and try to implement this. All right, so we'll have a couple of class variables here. Private priority queue of integers, min heap. Oops, I'm going to do it like that. Min heap equals new priority queue. So the default for the heap would be for integers would be a min heap. So we don't have to do anything special. You know what? I mean, now that I think about it, there's a constructor here that we're going to wind up doing nothing with. So let's actually do this. Let's put that there, and let's just define min heap like that, and then we can initialize it in the constructor. Okay, similarly, we can create a private variable for max heap. Max heap. So max heap also going to be a new priority queue, but we have to reverse the default order. So the priority queue has a constructor that will take comparator functions, and in this case, the comparator function. Oh, I'm sorry, it's not a comparator function. What is that? I'm forgetting what that's called. All right. I just looked it up. That is called a comparator function. All right. Let's see. So first thing we want to do when we get a number is min heap dot offer num, and then actually let's do this. Max heap offer min heap poll. Yes, now it's a little silly actually. Why did we put it on the min heap and then just take it off? Well, as we saw in the example, yes, if there's nothing on them, if the min heap is empty, then yeah, what's going to happen is we're going to put a number in it, and then we're going to take it right back out and put it in the max heap. However, as more numbers come in, it's possible that a number comes in that is greater than what is in. Wait, is that right? A number is going to come in that is less than the numbers. I'm sorry. A number is going to come in that is greater than numbers in the min heap. So when we do the min heap poll, we're not going to take off the number that we just put in. Okay, so that's what happened in the example when we put in the 3. There was already a 2 in there, so when we do min heap poll, the 3 stays in, the 2 comes out. All right, we've got to check and make sure that max heap is not getting to, that the heaps are still close to the same size. In particular, max heap cannot be more than, the size cannot be one. The size can the size cannot be more than min heap size plus 1. So if that is greater than min heap size plus 1, then we have got to take an element off of max heap and put it on min heap. All right, is that right? Off of max heap pull. Okay. Yeah, that should work. All right, and then find median. All right, so finding the median, as we saw, depends on whether the heaps are the same size. So if max heap size is greater than min heap size, so we have an odd number of elements, and so we can just return the top element of max heap. Okay. If we've got an even number of elements, then we return, let me just copy that. We return max heap peak plus min heap peak. I think I need parentheses here. Divided by 2.0, so we get a double. All right. I think that's it. Let's try and run it. Accepted. Huh. First time, no typos or anything. Okay. Scoot this over and submit. What did we get? Wow. The timing is not very good there. Let me think about this. Well, okay. I mean, I'm going to leave it as an exercise for the reader. I'm going to, check it myself. I know in the themes it said one of them was 2 pointers. So, maybe there's some way to do it where you just put everything. Well, see, I don't think that. Yeah, I mean, it might work. Where you put, I don't know, put everything in one priority queue and then use 2 pointers to converge both sides to the middle. But anyway, this works. It's simple, and that's it. So I hope you enjoyed it. Please feel free to like, comment, subscribe, and see you next time.